There is a comfortable story we tell about young designers. They are bursting with imagination, short of opportunity, and waiting to be discovered. Design festivals like the one held every summer at the Villa Noailles seem built to serve this exact narrative. They gather emerging talent, showcase fresh thinking, and applaud the next generation. But if you walk into any graduate show, you will find more genuinely good ideas in 3 hours than most large companies generate in a year. Imagination is not scarce in this field. A beautiful prototype made by hand in a school workshop is not a product. It is a physical argument that a product could theoretically exist. The distance between that prototype and a real product is not a lack of talent. It is the lack of contact with a process that will accept the idea and subject it to physical reality. What young designers actually lack is a tooling budget. They need a factory that will take a small run and put their shapes to the test. On the drawing board, a sketch is perfectly safe. In a real manufacturing timeline, a shape meets immediate resistance. Without that resistance, a designer is left guessing which of their beautiful decisions will survive injection molding and which will be quietly value engineered out by month 4. The romance of the unconstrained sketch is real, but it is how you end up with a proposal that dies in the first engineering review. The drawing was simply never asked a question it could fail. Contact with manufacturing is often seen as a compromise stage that dilutes a pure concept. It is the first honest interrogation the concept has had. A factory interrogates a shape through the parting line, where the mold opens. Then the draft angle. Walls must slope inward or the part won't escape the steel. Finally, the joins. Interlocking geometry increases operations and makes mass production harder. If you wait until the creative work is finished to answer these questions, you end up with a shape fighting its own production. Answer them early, and those mechanical requirements reach all the way back into the silhouette. They become the actual form language of the design. This understanding, that the machine gets a vote, has a long tradition. The Bauhaus structured their entire teaching model around it, putting students in workshops with craftsmen because a designer who has never turned metal designs metal badly. France institutionalized this practice through the Mobilier National, maintaining workshops that sit designers directly next to the people who physically make the objects. You can tell what an institution values by what it gives space to. Traditional museums collect finished, successful objects. Progressive design competitions tell you what a young designer actually needs. They hand out residencies, they offer real mentorships, and access to machines rather than writing a check. A check just funds another solitary prototype. A production partner forces a drawing to step out of the vacuum and meet resistance. There is a persistent assumption that the concept phase is the part of the process where constraints are absent. This timeline shows the opposite is true. The concept phase on the left side is where constraints are the cheapest to discover. The tooling phase on the right is where those same constraints are most expensive to ignore. There is a way to get this wrong, of course. Apply manufacturing contact too early and too literally, and designers internalize the mold before they find the idea. They end up drawing exactly what the factory already makes. The point is not to let the process dictate the shape. The goal is to discover which specific parts of a design the factory gets a vote on, while changing the file still costs you nothing. At Depix, we work in the phase before anything is committed to metal. We look for the 3 decisions in a proposal that a manufacturing process could veto, testing which ones are actually load-bearing. Ideas and unconstrained sketches are abundant, and they are only getting cheaper. A process that will take your idea seriously enough to test it against physical reality, that is the actual prize.